said, well, solve for x, solve the equation. So first of all, I realized that this is a natural log of an expression equals 2. I know that this expression has to be what type of number?
Greater than 0.
Excellent. So that's my first condition. 1 plus natural log x has to be greater than 0. Then I see another natural log. What is the restriction for this x? I have a restriction for this. Natural log has to be applied to positive, but I also inside I have natural log x. What is the condition now for x?
The same.
The same, has to be greater than 0. Okay. You can say, because this is a logarithmic inequality and it will take us a little bit of time for me to explain how this works, write the conditions. When you get the answer, whatever you get, let's say you get 7, put it in here and see if these two are fulfilled. If they're not fulfilled, 7 is not the solution. So this is strictly, this is very clear. But in order to solve such an inequality, first of all, I have to graph it. Okay? I will present the idea here, but I don't want to go through it because I want to finish this. So I'm just going to show, I just need another color. Where am I? Okay. So remember, natural log x is this graph. We know that. If this is not visible, I'll change it. And this is this side. But what about y equals -1? For y equals -1, I have this. This is y equals -1. This is y equals natural log x. So where is this above -1? Okay, so from here. So this is acceptable. And this is greater than 0, so this will be the domain. Okay? Because how do I know? Again, natural log has to be strictly greater than, this is open, strictly greater than -1. For which x values? From this intersection to the right. Okay. So then I will start exactly how we did it before. Natural log of an expression equals 2. How do I change this into an exponential equation?
E to the power of 2.
Exactly. E to the power of 2 equals 1 plus natural log x. Awesome. Of course, I have to subtract 1 first. And now again, another equivalency. E to this power equals x. E to e squared minus 1 equals x. E from here, the base, raised to this entire number equals x. So now all I have to do is approximate it with a calculator. But be very careful, because of course it requires parentheses. Even if it doesn't, I will still put them in. So I'm sharing my screen. I have the calculator here ready. So we have e to a power. E without a power is here, second and division symbol. But e with a power is right here. I will put parentheses, and it's e squared minus 1. So e with a power squared. Okay, I will omit the parenthesis up there. So e to e squared minus 1 definitely is going to be a number greater than -1 for sure, but we need more than that, right? So it's 595.3. 595.3. And I have no doubt that natural log of 595 plus 1 is definitely positive. And of course, this is definitely positive. Now, you can say, how do I check this? Is this true? Yes, it is. So here's how we do it. We are going to plug in natural log, parentheses, 1 plus natural log of this number, close the parenthesis, and see if we get 2. We have to. It's a must. So I have natural log, have parentheses, 1 plus, natural log again, of the previous answer. I'm not going to type this in. Second an answer. Oh no. Second an answer. Close the parenthesis and close another parenthesis. So this is what we were given from the get-go. Natural log of 1 plus natural log of this number. When I hit enter, I must get 2. If the answer is not 2, then 595.3 is incorrect. Now, if I recall this and not put 590 previous answer, and I just overwrite 595.29 and close, I will not get 2. I will get very close to 2, either in minus or in plus, but I will not get 2. Recalling the entire answer, the previous answer, it will always give me the exact. So when I press enter, it's not going to be 2, because this is an approximation. This is not the whole thing. So it's either under 2 or a little bit above, depending on how I approximated it. Okay? Good. Perfect question, Ev. Thank you. Next questions. Anything else you have for me before we start? Anyone? Okay, so what I have in mind to start with then is a problem. Where is my book? I lost my book. Okay, I want to look at a problem, and I let you choose, of course, if that's what you want. I want a problem. Why can't I go back? No, I didn't mean that. Okay, it's gone. Fine. I wanted to go back to a problem that requires us to look at doubling time. I didn't get the chance to show a problem like that. So do you think I can ever open this book again? It's embarrassing. Okay. I want us to be on page 205. 205. I want it 205. Can it open 205 for me, please? Okay, I think it's going to do it. So I like to look at something that has the doubling, either population, bacterial growth, just anything that has doubling time, so we can discuss that and move on. Anyone would like to?
Do 77.
Okay, perfect. Let's look at 77. Okay, so let me copy it. The city of San Esteban had a population of, okay, so 2015 represents t equals 0. Yes, and the annual percentage rate R equals 0.03. And the initial population, or principal if you want, is 45,000. Okay, so write a function. Fine. So A equals P e to RT, where P is 45,000, R is 0.03, and T is T. So this should be really written as A of T. T is the only variable here. And we have 45,000 times E to 0.03 T. That's it. All we had to do is identify what these represent and plug them in. That is our first step. Let's see what part B is asking us to do. Any questions on this? I'm trying to make sure it's in the middle. Okay. What will the population be in 2025? So year 2025. What are we trying to determine? It says find the population in the year 2025. We're specifically told that the starting point is 2015 when t equals 0. What does this represent? 2025 represents what?
10 years.
10 years. All I have to do is find a of 10. I will put this in the graphing calculator. Where is it? Okay, so I'm going to put it in because you know me, I like to see the function. If it's just one value that I have to evaluate it for, you may say, oh, it's not needed. But who knows, maybe I go back and check something else. I want the function to be there. So times e, and the power in parentheses 0.03. And of course, we don't have t, we have to use x, but it doesn't matter. So now with second and table, I will plug in 10. And let's see, it grows to, of course I can't, even if this is 6.4, I can't really consider 60,744 because I can't have 0.6 of a person. So when it comes to people, I would not round it up. I'm going to put both answers. For me, this is the correct answer. 60743 people. If you want to consider the rounded up, then you will say 60744. Okay? I'll put both. Sometimes these books require different things. So both. Fine. Back to, I didn't mean to change that. Okay. When will the population reach 55,000? Part C. And then when will the population double in size? Okay. So it says when will the population be 55,000? And for D, double in size. Okay, so these two are asking when. So what am I asked to determine? What does when represent?
T.
Yes, means time. So t and then year. So if I find that t equals 20, then I have to add 20 to 2015 and say 2035. If I find that t equals 15, then I'll say whatever. I have to add. Good. So how do we address this first? Where is my starting point? What do I have to write first?
A is 55,000.
Yes. So I have for part C, 55,000 equals 45,000 e to 0.03 t. Perfect. So what am I trying to do now? How do I continue?
Divide by 45,000, you said?
Absolutely, I have to clean it up. So divide both sides by 1,000 and then 55 divided by 45 equals e to 0.03 t. Yes, I can further simplify by 5, but who cares? What is my next step? In finding t.
Both sides times ln.
Yes, apply natural log to both sides. So that's why I don't even care to simplify this. Okay, so then I have natural log 55 over 45. Remember what happens next. Goes in front as a factor, the whole thing. 0.03t. There is no need for parentheses because it's a multiplication, but if I had plus, I would have had to put in parentheses, or minus, of course. How much is natural log e? I should write here times natural log e. Why don't I?
It's 1.
Because it's 1. That's why I didn't need to. Good. So then t equals this number over this number. Be careful, do not separate this. We plug it in and we approximate. Okay, so I have natural log of 55. See, it already pops up with parentheses because that will not work without it. And the whole thing is divided by 0.03. And I press enter, and I get approximately 6.7 years. Which year will that be? Knowing that 2015 represents t equals 0. So we're adding this. So 2021, 0.7 if you want, but you know what I mean. In the year 2021. Now, how do we perform the last one? How do we work on double in size? I was told the population is 45,000. What does the double in size mean? What will the population be if it's double in size?
45,000 times 2.
That's it. And that's exactly how I'm going to write it. 2 times 45,000 equals 45,000 times e to 0.03t. Why? Because I divide both sides by 45,000. What's the point in multiplying and writing 90,000? So the equation is now 2. Oh yeah. I thought I missed something. 0.03t. Good. And now exactly the same procedure. I apply natural log to both sides. Everything is the same. Natural log 2 equals 0.03t. So I divide by it. Exactly the same steps. The exact same steps. Again, I plug this in the graphing calculator. I can't do this by hand. No one can. Okay, so all I have to do, that's how lazy people do it. And I just go in, and I put 2, and I delete the rest. Natural log 2 over 0.03. So 23.1 years. When is that? So 23 plus 15. So this is 2038 in the year 2038. 2038. That's the whole trick with that doubling time. What you're given, what if we're asked to triple? You're going to apply the same procedure for triple. You will be 3 times this, and you will perform the calculations with natural log 2 being natural log 3. And that is it. Any questions? Oh, there was one other thing that I wanted to show you in class, but you have to remind me which problem was that. I forgot. With the last, the limit. There was a problem that I said, please don't do the last one. I want to show it in class. Can anyone remind me which one? Was it 82?
Yeah, it was 82.
82. Okay, let's talk about that. Because there is nothing wrong with it. But since I did not have a problem like this in class, I just wanted to show it to you first.